In their large steel and tube works, Stewart's and Lloyd's experienced no difficulty in producing, amongst their many other wartime demands, the 1,000 miles of pipe required for this project. It was everyday work for these 30-foot lengths of steel bar to be broken into billets and fed into the furnace. And these men had not the slightest inkling that they were contributing to the success of a vast and ingenious undertaking. To them it was just Job 99, something urgently needed for the war effort. The production of this additional tube was in fact only a small part of the activities of the company, whose output of steel tubes during the war exceeded 275,000 miles, enough tube to encircle the globe 11 times. Now, the billet that was is elongated to a tube of some 30 feet. The ragged ends are sawn off and the tube enters a reducing mill, where again it is elongated to emerge a Pluto tube of the required dimensions. From the cooling racks, the tubes are taken to be descaled and coated to prevent rust. No rust or scale must endanger the flow of petrol. Every tube must pass the grading test to ensure that only those of correct carbon content leave the mills. By this meter, any difference from standard is easily detected. Special plant and equipment had to be devised to make these tubes into pipelines up to 80 miles in length, and this was the method eventually decided upon. In the welding shop, the lengths are carried along conveyors to the inspection bench. Each of the 14 production lines is a complete unit in itself, consisting of a welding machine, 2 types of trimming machines, and a traverser. The inspector checks whether the tube has sustained damage during its journey from the mills. Satisfied with his examination, he applies a spot of paint and stamps the tube with his code letters. At the cleaning table, the protective coating is removed from the ends by spirit, the steel polished with emery cloth and filed to leave a clean, smooth surface for the electric contacts of the welding machine. This shows the procedure for starting an entirely new 3/4 mile length of pipeline. A tube is pushed through and beyond the grips of the welding machine. A bung is inserted in the nose end and the pipeline's identification number painted near the end of the tube. By hand, the nose end is moved forward into the trimming machine while the open end is positioned in the welding machine. The latch plate is dropped to prevent any forward movement of this tube when the internal flash removal tool is sent forward through its entire length. It is fitted with cutters to remove the obstructing metal, holes through which air is forced to cool the weld, and brushes to clean the bore. As the tubes are welded, a flash or flange of metal and the spattered metal from the welding is left inside, which, if not removed, might cause obstruction. The problem of how to remove this called for extensive experiments before this tool head was developed. The tool head emerges, proving the bore to be clear, and the latch plate is lifted, allowing the tool head, now carrying the tube forward, to enter the tube into the welding machine. The tool head is now beyond the welding position, so that the dust and swarf removed by the cutters may be drawn out when the ends are welded. If the tool head were to be passed through after welding, the dust and bits of metal would be pushed forward into the longer length of pipeline. The weld commences. It should be noted that an inspector must be present during the entire operation. Notice how the pointer indicates that the right-hand head is creeping forward. When the flash cuts out, it will dart forward, forging the weld. As the weld cools, charts are checked for consistent flash current. With welding and cooling completed, the flash remover is brought into use, and this cutaway section shows clearly what is happening. The shaft is rotated and the cutters brought back to remove the flash left inside after welding. After cutting and brushing small bits of metal from inside the weld, the tool head is withdrawn, sweeping clean the length of the bore. And the machine is reset for the next weld. The nose end is hand-fed into the traversing machine, which grips the tube and carries it forward. The next operation is to trim the flash, which is also left on the outside of the weld. As the tube leaves the trimming machine, the inspector makes sure that the cutters have not cut into the wall of the tube. If they have, the weld would be cut out and the tube ends re-welded. The whole success of this great undertaking depends on perfect welding. As well as routine tests at Tilbury, laboratory tests and examinations under the microscope were carried out at Corby on weld specimens sent from the production lines. Sections cut from the tube wall underwent the repeated bend test, quality being checked by a comparison of the number of reversals required to break the weld with those required to break the parent metal.